So here's the first problem, rate problem. A boat which moves at 18 miles per hour in still water. So it's not affected by the rate of the river. It travels 14 miles downstream in the same amount of time it takes to travel 10 miles upstream. Find the speed of the current. All right, so we're solving for the speed of the current of the, is it the river? Or okay, it's a river because we have a downstream and upstream. In order to solve for this, we have to use the blueprint in solving word problem. And that is summarized into four steps. If you're familiar with this, it's a blueprint similar to the Polya's steps in solving word problem. But I use this acronym RESA. And so what's RESA? Well, what does RESA stands for? RESA, R is for representation, E is for equation, S is for the solution, and A for your answer. So let's go to the first step here, which is R. We represent, okay, so let X be the speed of the current. That's what we are looking for, the speed of the current. So let that be X. In order to find our equation, we must put this in a table. Since the rate is involved, distance is involved, and what else? Time is involved. Then we have to make use of the DRT table. Do you remember the DRT table? Distance is equal to rate times time, right? So with the DRT table, you have here, okay, let me just, oh, create a table here. So let this be your distance, rate, time. We can divide this into two because we have the downstream into two rows. We have the downstream. Okay, let me write that more legibly. So the first one is the downstream. And then we have upstream. For the downstream, what's the distance? Do we have a distance? Usually, how do you know if it's a distance? The unit for distance usually kilometers, miles, meters. All right. So those are your distances. So what's the distance downstream? It is 14. All right. So it is 14 downstream and then 10 miles upstream. So let's put here 14 and then upstream, let's put 10. This is in the same amount of time, right? So what's the rate? The rate. The rate downstream and the rate upstream. Remember that your rate from our formula here, distance equals rate times time. That means that, okay, this is a formula triangle. I hope you know how to use the formula triangle. Distance equals rate times time. So that when you are looking for distance, then that would be rate times time. When you're looking for time, this would be distance over rate. When you're looking for rate, it would be distance over time. So what is your rate now? Rate here is simply distance over time. And also time is equal to, let's write that again. Time is equal to distance over rate. But let's see which one here is needed. We cannot use all of the three formulas. D equals RT, R equals D over T, or T equals D over R. For the rate, A boat which moves at 18 miles per hour in still water. So that's the rate of the boat in still water, right? So what's the rate of the boat in, I mean, going downstream? It would be 18 miles per hour plus the current, right? So when you go downstream, there will be two speed that will make you faster traveling downstream. That is the rate of the boat plus the rate of the current. So that would be 18 plus x. That's why you are faster, because it's not only the rate of the boat, it's also the rate of the current. So you're faster when you go downstream. 18 plus x. But now you go slower when you go upstream. Why? What makes you slower? The rate of the current will make you slower because you are going against the current. So you're going upstream, so that will be decreased. That 18 will be decreased by that speed of the current. So that will be 18 minus x. So just remember, if we're downstream, it's plus the speed of the boat in still water plus the speed of the current. If it's upstream, you'll go slower because your speed will be decreased by the speed of the current. So it's 18 minus x. How about the time? We can come up with an expression for the time. And that time, since we do not have anything about the time, there's no time here, right? Since there's no data about the time, we can make use of this. T equals distance over rate. And do we have a distance? Yes, we have 14. We have a rate. It's 18 plus x. So the expression that will define your time for downstream is, all right, I don't have space here, so I can just put it here. 14. Can I write it? Distance over rate. So that would be 14 over. No, you could not see it. Okay, let me make the table bigger. Let me make that bigger. So this is a distance, this is your rate, and here's your time. Distance, you have 14, 10. Rate here, it's 18 plus x. Where did we get 18? The rate of the boat here in still water. Why did we do plus? Downstream. It's faster, so it's plus x. Slower, 18 minus x. And now your time, based on this formula, it's distance over rate. That's 14 over 18 plus x. And then the other one is 10 over 18 minus x. So this would be our table, the DRT table for rate problem. So that's our table, and we can make use of this in order to find our equation based on the idea that the same amount of time is taken for both downstream and upstream. What do we mean by same amount of time? When it's the same amount of time, then what's the relationship between these two times here? Between the time downstream, which is 14 over 18 plus x, and then upstream, which is 10 over 18 minus x. These are the same time. That means they are equal. And so we can come up with this equation. What equation is that? That equation is this. It's 14 over 18 plus x equals 10 over 18 minus x. So that's our equation based on the problem. We try something before we solve this. The speed downstream, right? The speed downstream, this is based on speed. The speed downstream is simply the sum of two speeds. And what is this? It's the rate in still water plus rate of current, right? So that's the formula for downstream rate. For upstream, it's simply minus. So just remember this whenever you represent your downstream and upstream rate. This is rate in still water minus rate of current. So those are two formulas you have to remember when you are solving for, when you're representing rates. Rate downstream is simply rate in still water plus rate of current. Upstream, rate in still water minus rate of current. Those are two important formulas in solving problems about rate involving downstream and upstream. This is similar to with the current and against the current when you are traveling in the ocean, in the sea. But these terms are used when you are traveling in a river. Have you been in a river? We don't have river here, only ocean and sea. When you go to places like I don't know if they have a river in Ponape. Okay, US has a lot of rivers. Other countries, Asian countries has a lot of rivers. Here we have big body of water, the ocean. And so instead of using downstream and upstream here, we cannot use that. We can only use with the current and against the current. All right, so let us solve this equation. 14 over 18 plus x equals 10 over 18 minus x. This is a rational equation which can be solved by simply doing cross multiplication. So we can cross multiply, right? Cross multiply. So what do we have now? We have 14 times 18 minus x equals 10 times 18 plus x. So that's how cross multiplication works. It's easier than using LCD. We can also use LCD here, but cross multiplication is not always applicable. It's not always applicable. But in this case, it's applicable because we have a proportion. We have a ratio and a proportion. How do you know it's a proportion? It's a ratio and proportion. It's a ratio and proportion if we have one fraction bar on both sides. And there's only one expression on both sides. So 14 times 18, what's 14 times 18? Let's multiply that. This is 32. 8 plus 3, 11. We have 14, 2, 5, 2. All right, so this is 2, 5, 2 minus 14x. And 10 times 18, 180 plus 10x. Combining like terms, you now have here, let's get 10x to the left side. So we subtract minus 10x. Minus 10x. We also have to get rid of this constant term here, 252. So we do minus 252 minus 252. This is now 0. This is negative 24x. This is 0. And what is 252 minus 180? You have 2. You have 7. Okay. So negative 72. All right. Solving for x, we divide both sides by negative 24. So with negative 24, x equals negative 72. Divide negative 24 both sides. Cancel this. So what's your x? 3. What's the unit? We are talking about the speed. So what's the unit for speed? It depends on our speed of the boat. Miles per hour. So same unit with the boat. So that is 3 miles per hour. Or you can say x equals 3 mph. And we are done. That's our answer here. The speed of the current is 3 miles per hour. Why is it important that the speed of the boat is higher? I mean, faster than the speed of the current. What do you think will happen if the speed of the current is faster than the speed of the boat? You will not go anywhere, okay? But the current will take you anywhere it wants. So make sure that you are faster than the current. Well, of course, you're faster than you should be faster than the speed of the current. Otherwise, if there's a typhoon, then it might be that the speed of the current is faster than your boat. But that is a tragedy if that's the case. So don't go into the ocean if there's a typhoon. Otherwise, it will bring you anywhere, or else it will bring you to the bottom of the ocean. And you'll have peace there forever. Just kidding. All right.